Hello everyone and welcome back. In the previous video, we learned how a security operations center responds to security incidents. But have you ever wondered what happens after an incident is resolved? How does the SOC ensure that the same attack is detected automatically in the future? The answer is use case management. In this video, we'll learn how SOC analysts design, build, test, and continuously improve detection rules that help identify cyber threats before they become serious incidents. What is a detection rule? A detection rule is simply a condition that tells the SIEM when suspicious activity should generate an alert. Think of it as an "if this happens, then alert me" statement. For example, if one user fails to log in more than 10 times within 5 minutes, generate a brute force attack alert. Detection rules allow analysts to automatically identify malicious behavior without manually reviewing millions of log events. What is a use case? A use case describes a specific security scenario that an organization wants to detect. For example, detect ransomware activity, detect impossible travel logins, detect PowerShell abuse, detect privilege escalation. Each of these represents a separate use case with its own detection logic and investigation process. Where do detection ideas come from? Detection ideas don't appear randomly. SOC teams build new use cases using information from multiple sources. Previous security incidents reveal gaps in detection. Threat intelligence provides insight into emerging attacker techniques. Threat hunters discover suspicious behaviors. Compliance requirements define mandatory monitoring controls. And the MITRE ATT&CK framework helps analysts understand how attackers operate. Together, these sources drive continuous improvement of the SOC's detection capabilities. Writing detection logic. Once a use case has been identified, analysts begin writing the detection logic. The logic defines exactly what activity should trigger an alert. For example, if multiple failed login attempts are immediately followed by a successful login from the same account, the SIEM generates an alert for a possible brute force attack. The goal is to detect suspicious behavior while minimizing unnecessary alerts. Mapping to MITRE ATT&CK. Every mature SOC maps detection rules to the MITRE ATT&CK framework. This ensures analysts understand which attacker techniques are being detected and, more importantly, which techniques still have no coverage. MITRE mapping also helps organizations measure the maturity of their security monitoring program. Testing the rule. Before a rule is deployed into production, it must be tested. Analysts use historical logs, simulated attacks, or red team exercises to verify that the rule behaves correctly. If the rule misses attacks, it must be improved. If it generates too many alerts, it also needs refinement. Testing ensured the rule provides value before reaching the SOC analyst. False positives and fine-tuning. One of the biggest challenges in detection engineering is reducing false positives. A rule that generates thousands of unnecessary alerts wastes analyst time. But a rule that is too restrictive may miss real attacks. Detection engineering is all about finding the right balance between sensitivity and accuracy. Deployment. After successful testing, the detection rule is deployed into the SIEM. From that point onward, the SIEM continuously evaluates incoming events against the rule. Whenever the conditions are met, the rule automatically generates an alert for the SOC team to investigate. Continuous improvement detection engineering never stops. Every investigation provides new knowledge. Analysts continuously update existing rules, create new use cases, and improve detection coverage. As attackers evolve, detection rules must evolve as well. This cycle of continuous improvement is what makes a mature SOC more effective over time. Real-world example. Let's look at a real-world example. Suppose an attacker performs 20 failed login attempts before finally guessing the correct password. Immediately afterward, the attacker disables multi-factor authentication. Individually, these events might not appear suspicious, but when correlated together, they strongly indicate account compromise. A well-designed detection rule recognizes this sequence and immediately alerts the SOC. Key takeaways. Let's summarize what we've learned. A use case defines what we want to detect. A detection rule defines how we detect it. Every rule should be tested before deployment. Mapping to the MITRE ATT&CK framework helps measure detection coverage. And finally, detection engineering is a continuous process of learning, refining, and improving. Every incident becomes an opportunity to build stronger detections for the future. Thank you for watching.